Welcome to Astronomy Daily.
The podcast bringing you the latest in space and astronomy news. I'm Avery.
And I'm Anna. Today we've got a busy show. We'll be talking about an Australian satellite that's taking selfies in orbit,
A close encounter between US and UK military satellites, and a busy week for rocket launches around the globe.
plus we'll dive into some fascinating new research that questions the existence of so-called water worlds.
And we'll have some quick headlines, including a potential signal from a wormhole. Let's get started.
First up, let's head down under. Australia's Spirit Nanosatellite has just wrapped up its first mission phase after an impressive run.
Impressive is right. It's been in orbit for over 600 days, circling the Earth more than 9,000 times since it launched on a SpaceX Falcon 9.
For a satellite that's only about 11.5 kilograms, that's quite a journey. The initial phase was all about checking its systems, making sure everything was working correctly.
And they did this in the coolest way possible. It has a selfie stick to take a photo of itself against the backdrop of Earth. I love that. It confirms everything is deployed and operational.
It's not just for show, though. Spirit's main job is pretty serious. It carries an instrument from the Italian Space Agency designed to detect gamma-ray bursts.
And this is where it gets really clever. Spirit also has a built-in autonomous repointing system. So when it detects a gamma-ray burst, it can automatically and very quickly turn itself to face the source of the explosion. This allows it to gather more detailed data in the crucial first moments.
That's a critical capability. Often the most interesting information from these events fades very quickly. By reacting instantly, without waiting for commands from the ground, Spirit can catch details other telescopes might miss. It's a great example of how AI and automation are transforming space science.
And for our listeners, gamma-ray bursts, or GRBs, are some of the most powerful explosions in the universe. They come from incredible cosmic events, like two neutron stars colliding.
Exactly. The idea is that Spirit is a pathfinder, a prototype for a future constellation of satellites. This network will be able to quickly spot these gamma-ray bursts and alert astronomers on the ground so they can point their telescopes at the source almost immediately.
It's a fantastic example of international collaboration and a big step for the Australian space industry, a tiny satellite with a huge mission. Next, we're moving from scientific collaboration to a major display of military partnership in orbit. The U.S. Space Command just did something for the first time ever with the UK.
They performed what's called a rendezvous proximity operation, or RPO. In simple terms, they flew one of their spacecraft very close to a UK military satellite to inspect it.
And this wasn't in low Earth orbit. This happened 22,000 miles up in geostationary orbit, where many critical communications satellites live. The U.S. spacecraft approached the UK's Skynet 5A communications satellite.
The official line is that this was a peaceful inspection, a demonstration of trust and cooperation between allies. It shows they can help each other out. Say, if a friendly satellite is malfunctioning and they need a closer look.
But there's another layer to this, isn't there? It also sends a very clear message to other nations. It demonstrates a capability to get extremely close to any satellite in that orbit, friendly or otherwise.
That's the subtext, yes. U.S. Space Command's General Stephen Whiting didn't mince words. He called it a demonstration of the war-fighting advantage their coalition provides. It's a powerful statement about their capabilities in what's becoming an increasingly contested domain.
So, a friendly checkup, but with a very strong geopolitical message attached.
Speaking of people in space, we should mention that NASA just introduced its newest class of astronauts.
That's right, the 24th class. It's a diverse group, and one interesting name on the list is a former SpaceX crew member who was part of the all-civilian Inspiration 4 mission. It's great to see that pipeline from commercial spaceflight into the official NASA core.
It's been a very busy week for launches. Let's do a quick roundup.
Let's start with the usual suspect, SpaceX. On Monday, they launched another 22 Starlink satellites from Cape Canaveral. What's amazing here is the booster they used for this Falcon 9 flight. It was its 15th trip to space and back.
That reusability is still mind-boggling. Over in New Zealand, Rocket Lab is gearing up for its 53rd Electron launch. This one is for the U.S. Space Force and has a very cool mission name, Methane to be MAX.
I like that. So what's it doing?
It's deploying a satellite that will try to demonstrate producing methane in orbit. This is a key technology for in situ resource utilization. The idea is to eventually create rocket fuel from resources found on the moon or Mars, like water ice and the Martian atmosphere.
So you wouldn't have to carry all your return fuel with you. That's a game changer for long-duration missions.
Absolutely. And finally, not to be left out, China also had a successful launch, sending up the Yaogan 44 reconnaissance satellite on a Long March 2D rocket. A busy week for all the major players.
Okay, before we get to our last big story, I have to bring up this wild theory I read about. Remember that strange gravitational wave signal from 2019, GW 190521?
Vaguely. It was very short, just a blip, right? And it seemed to come from the merger of two unusually massive black holes.
Exactly. But it was so odd that it's opened the door to more exotic explanations. A new paper is floating the idea that it might not have been a standard black hole merger at all. They suggest it could be the echo of a collision that happened in another universe, and the signal traveled to us through a wormhole.
Wow. Okay, that is definitely out there. I assume the standard black hole explanation is still the most likely one, right?
Oh, absolutely. But the scientists say they can't completely rule out this wormhole hypothesis based on the data. It's a fun thought experiment, if nothing else.
All right. For our final story, let's talk about the search for alien oceans. For years, there's been a really exciting idea about a type of exoplanet called a Hycean world.
Right, these are sub-Neptunes, bigger than Earth, but smaller than Neptune, that are thought to be completely covered in massive deep oceans. The quintessential water world from science fiction.
The theory was that these planets could form with a huge amount of ice, which would then melt into a global ocean. But a new study is pouring a little cold water on that idea.
Pun intended?
Of course. New computer models suggest that it might be very difficult for these massive oceans to exist on the surface. When these planets form, the immense pressure and heat in their interiors would cause a chemical reaction.
Let me guess, the water doesn't stay on the surface.
Exactly. The hydrogen and oxygen that make up the water would likely get trapped deep inside the planet's molten mantle. The study concludes that planets with oceans making up 10 to 90% of their total mass are very unlikely.
So the dream of a planet like Camino from Star Wars might be less realistic. This is particularly relevant because of the recent hype around exoplanet K2-18b, which some had claimed could be one of these Hycean worlds.
This research definitely tempers those expectations, but it's not all bad news for the search for life. The study also suggests that the same process would make it easier for planets with more modest, Earth-like amounts of surface water to form.
So fewer giant water worlds, but potentially more planets that look a little more like home. I'll take that trade-off. It's a great reminder that our assumptions about how planets work are constantly being tested and refined.
And one last quick note for all the stargazers out there. A brand new comet has been discovered, and it could be a good one.
Ooh, tell me more.
It's called C/2025 R2.SWAN. It's already quite bright, and there's a chance it could become visible to the naked eye this October. For now, you'll need binoculars to spot it.
When's the best time to look?
It will make its closest pass to Earth on October 21st, so mark your calendars and keep an eye on the sky. It's always a treat when a new visitor graces our cosmic neighborhood.
And that's all the time we have for today on Astronomy Daily.
It certainly has been a full week. To keep up with these stories and more, be sure to visit our website.
Visit astronomydaily.io for more space and astronomy news, and to listen to all our back episodes.
We'll be back tomorrow with more space and astronomy news for you. See you then. I'm Anna, signing off.
And I'm Avery saying bye for today. Make sure you get outside and look up.
You never know what you might see.